All right, well, good afternoon, everybody, and thank you for joining this 8th annual Simulation Century event. For those of you who have been attending this event as part of Mod Sim World in the Norfolk and Bay Area of Virginia for the last 8 years, this is our first virtual version of this, but we didn't want to skip a year because there's so much happening in this space. As you know, this is something we've held every year for the last 8 years. We have been advising, using this to advise all the services, including Joint Forces Command, on some of the progress we've been tracking in machine learning, artificial intelligence, but especially simulation. The general idea, the original idea for Simulation Century was that the last century was about the televised image. It was the first time in human history when humans would actually reflect upon current events and recent or past events by reviewing footage of it. And that changed how we thought about history, how we formed history, and how we interacted with each other around that information. Think about, being able to tune into the Vietnam War every day on the news and reflect upon what's actually happening there by looking at footage. There's a guy named Marshall McLuhan who talked about this idea that the media we create actually creates us in turn. So we've been all formed, those of us who are baby boomers, and I'm the last of them, I think, born in 1964. Our brains were formed from this media type by interacting with televised media. And now in this century, there's a whole new set of media types that are forming us for good or for ill. So we want to track that and understand what's happening. But my thought here originally was that in this century, it's about harnessing the power of computing, emerging technologies like machine learning, artificial intelligence, to be able to simulate and predict and even influence future events. And those entities, whether individuals or companies or governments who become adept at that, will prosper and will outperform those who don't grasp these technologies and this ability to simulate and form the future. So that's the general idea. I'm really pleased today to have some really compelling speakers to provoke you, and that's always been the point of Simulation Century, is to be provocative, to really get you to think about the implications of these technologies and how they can be put to good service, but also to think about how they might be misused and make sure that we're putting up some guardrails around some of that. So some of the folks that are joining today are Heather Flannery, who will be talking to us about blockchain and Ethereum and how that applies to healthcare. Wayne Gafford's here from the Navy with OpNav N12 with some really exciting ideas. And Michael Levy, who's the president of the Digital Health Institute for Transformation, unfortunately just pinged me, and I think this is a sign of the times that during this pandemic, he has got a medical emergency with his family, and I don't know the details, but he won't be here today, but he did send me his information. I'm reasonably familiar with it, so I'm going to do my best to cover at least the provocative ideas that he wanted to share with all of you. And at the end of this, we will have some time for Q&A from those of you who are attending live in this session. So we look forward to hearing from you. You can do that either in chat, or we could even, because we have that capacity here with Zoom, we could even call on some of you to actually speak your question. But if you have thoughts as we're going through all of the talks, feel free to just put those into chat, and we'll be looking through those, and we can actually pull from those as we get into Q&A. All right, so I'm gonna go ahead and jump in here. And I assume everybody's seeing my screen okay, right? And I've talked through what some of the core concepts are here. One of the ideas, and I'm just going to start by tracking how we've been looking at progress over the last 8 years. From the very beginning, when I first did this in 2012, we talked about this idea of the technological singularity. I think most of you today are already very comfortable or already familiar with this idea, but this came originally from Vernor Vinge, a science fiction writer who I've met, and some of my colleagues I know him out of San Diego, where he said, it's possible that, we're getting near this point where the technologies we're creating will actually exceed human intelligence. And when that happens and they have their own ability to self-improve, we really can't see beyond that. It may be the last invention humans ever make, because once they can self-improve, it's going to go, and we can't really predict what's going to happen after that. Years ago, in the early 2000s, a guy named Ray Kurzweil wrote a book called The Singularity is Near. And he was saying that in 2003, I think, when that book came out. And so I've been tracking that ever since. And we've been tracking it as part of this session every year to say, we're slouching towards it. We're getting ever closer. How close are we? What changes are we seeing? How's it affecting society and the man-machine relationship? And what do we need to be thinking about? So I always like to pull this little chart you see in the lower right here that was in his original book. I hear today when he talks, he says, oh, it's now 2028. And I've always said it was 2028. But when you publish a book and it's in hard format, you don't get to edit it. So he actually said back then it was 2023. Think about it. That's only 3 years away. Supposedly 3 years from now, according to him, $1,000 worth of computing will exceed the power of a human brain. Now, I personally don't think we're anywhere near that. I'd love to hear what other people think about this. I think, on the high level with some of our supercomputers, I think we are getting close to that. But in terms of $1,000 worth, it's hard for me to see, this close to 2023 that will be there. But I think we're already starting to hear a few bumps in the middle of the night from supercomputers, especially quantum computers, in terms of the ability to compute and potentially have more power than the human brain. But whether or not it actually becomes something that self-improves and is smarter than a human, we already know that there are certain areas of human endeavor where machines are better than humans. And we've been tracking that every year. Go back through the Mod SimWorld website and look at all the presentations that we've talked about over the years, where I've had, I like to bring different people in to talk about these ideas. One of the first ones we were just talking about before the session started was Charles Simonyi, the guy at Microsoft who invented Microsoft Word and Excel. He's one of the early Microsoft billionaires, also dated Martha Stewart and went to space and all these things. I've also had, for example, the producer for Dr. Dre, in music, talking about, we've already gotten to this point. I think this was 3 years ago. He was demonstrating machines that could actually compose and play music that was sort of indistinguishable from, and very pleasant music that you would totally believe that a human being had created that or composed that. So we're seeing these little barriers dropping pretty quickly. Today, I'm on the board of trustees of a very large community college here in North Carolina that has 70,000 students. And when I run into someone who's like, oh, I want to go into radiology, for example, I have to pull them aside and say, you really need to think about this because, yes, radiology today is still something that humans do, but we have machine systems right now that are far better than any human expert at actually reading X-rays, for example. And that this list of things that can be automated by machines is getting longer and longer and longer. And that's why we have to really be careful about thinking through what kinds of jobs we're going to have for people in the coming decades, not just 2023, but 2030 and beyond. And what does that mean for society? So this is just part of the structure here. So we're tracking this progress. I really don't think we're going to have $1,000 worth of computing be smarter than a human brain in 2023, but very interested in chat or whatever. If you guys want to post what you think about that, interested in hearing that. So the other thing we always track is Gartner, right? And I see my colleague Kevin Clark from IBM is on here, who has made a sort of a avocation out of studying how Gartner tracks all these various technological curves. I think everybody's familiar now with the hype cycle that they produce every year. They used to do just sort of one around general information technology, but now they have all these specialized ones. The one of them that we track at Tanjo, and I know a lot of the people in the audience here will be tracking carefully, is the hype cycle for artificial intelligence. Now, I really believe that some of these things, especially what I've circled here in machine learning, Gartner even at 2019, and I haven't seen the 2020s yet. I was looking for them. I've seen some, I haven't seen the full hype. Maybe they're just really right now, or maybe they're like so many people so flustered by the pandemic they haven't got those charts out yet. But when they have machine learning still at the peak of inflated expectations and heading towards the trough of disillusionment, I have trouble with that, because I really think for certain parts of machine learning, we're already well past it, up the slope of enlightenment. There are applications today of some basic machine learning. You can call it not deep learning, but shallow learning, where we can automate tasks that we already know humans should not be doing, because these machine systems are so much better than humans. In a previous version of, or a previous event, I talked about in 2017, I believe, my firm built a system that could read sales agreements and audit them for an entire company, millions of sales agreements, and apply rules around revenue recognition and lease recognition. And there were some new rules that came out that year from FASB. And then that year, the accounting firms were trying to figure out, like, how do we prepare ourselves? How do we prepare our clients? And we looked at that and said, that's a classic machine learning problem. It can be solved very quickly. It was done in 3 or 4 months. And that you have a system that was stood up very quickly that could do it 10 times faster than humans could. And it was pretty straightforward to do it. So I believe that some of those low levels of process automation are already to the point where they're almost a commodity. So I don't know why they don't have that sort of called out here, but I'd say they're way up the slope of enlightenment and already into the plateau of productivity, where they have GPU accelerators and speech recognition today. But again, I'm interested in hearing from this learned audience and anyone else who wishes to comment about what you think about that progress. Now, the other thing we're looking at is emerging technologies. This is one of the first ones I look at every year, where, especially things like autonomous driving, level 4 autonomous driving, level 5 autonomous driving. I don't know if you guys have really tracking that carefully, but level 4 is something where I think some Teslas are getting, I think Tesla is pretty close to that already. I don't know why it's in the trough of disillusionment, because level 4, as I understand it, is, a human driver is driving around town and that sort of thing, where there's a lot of input output really happening. So you really don't want to overly trust the car to drive in those environments. But once you get out on a highway, I know many of us have, if you're like me, I've passed people in Teslas who are almost reading or on their iPads while their car is just driving down the highway at 70 miles or 65 miles per hour precisely, and seeing that their comfort with that. So I think level 4 is already there. Level 5 is a little bit more difficult, and that's where you're really trusting the autonomous driving system to drive in all conditions, where you're really not paying much attention anymore. I think we are a bit further away from that. But some of these other areas I think are really interesting. Edge analytics. We'll talk about hopefully some of this stuff today and in future sessions of SimCentury, no doubt. So let's also talk about the trends, and we'll call out some of the trends. Some of the technologies that Gartner mentioned at the end of last year as trends to watch in 2020. Again, pre-pandemic, I think is when they published this. But already they were looking at 5 or 6 things, and that's kind of in that first block of words there: hyperautomation, blockchain, AI security, distributed cloud, and autonomous things like driving that were up in their top list of technology trends that are going to become really strategic this year. So we have several of those topics here today, but primarily this idea of hyperautomation. And for me, hyperautomation is going a little bit beyond just thinking around this basic idea that we've talked about in previous years, that the real issue for the century is thinking about what should humans be doing and what should we be turning over to our to machine intelligence, to machine effort and machine attention. And I like to separate those two things out. There's no doubt that machines have better attention spans than most humans, but the intelligence side of it is a moving sort of solution where almost every month the answer to what you should be doing in your own organization in terms of looking at all the tasks and figuring out a human should be doing this, but this portion of the task should be turned over to some kind of automated system or automated attention monitoring capability that will give you a better solution than having humans do it by themselves. That balance is key. And like I said, the where that slider is located is moving just about every month. And we are getting beyond just level use of automation like bank tellers and other forms of automation into something where you can turn over lots of various kinds of operations to automation. And then I'm very pleased to have Heather Flannery here with us to talk through blockchain. There's almost no conference today is complete without talking about that and the implications of blockchain for where we're headed and what it means to our financial systems and again, we'll differentiate between the currency part of it and just the blockchain in terms of security and how we deal with privacy and that kind of thing, which is overall what we want to talk about. Just a few more quick things before I start handing it over. Years ago, 6 or 7 years ago, we said, I shared this screen and I said, be prepared for accelerating technology, disappearing jobs, and double-digit unemployment, which really didn't happen until now, until this pandemic really put it into sharp focus. But we expected to see double-digit Dow returns, which we have seen, regardless of what kind of tumultuous societal problems we're dealing with. The Dow returns keep increasing because we are seeing increased productivity. And because of the first item there, we expect to see more reliance on government. And again, this pandemic and some of the other civil unrest issues are putting this all in sharp relief. And we've got to figure this out really quickly, and we need help. One of the jokes I've always said in these sessions is, we poor dumb humans haven't had an upgrade since the Pleistocene. So we need to learn to accept this help from this machine intelligence and become fluent with it so that we can harness it and solve these really complex existential issues that we have. And you see at the bottom there that I mentioned that, the Industrial Revolution kind of started this and created this, put all this in swing. But in the Industrial Revolution, things were just moving slower. So in 1800, 90% of everybody in the US worked in agriculture. In 1900, it was 41%. Today, it's 2%. So we had 200 years to adapt to these trends. Unfortunately, now I don't believe we have that much time. The singularity is creeping up on us. All these trends are accelerating. Some of the other issues of globalization and growth of the human population on the planet are creating more tensions, are making it more likely we're going to see more pandemic events. We've got global warming to deal with weather events and that sort of thing. And we've got to achieve this fluency to address these issues. And overall, this is the other thing we track every year, is it really boils down to this. For those of you who are economists, if you really want to distill all this down, it's really the age-old several hundred-year battle between capital and labor. This is a video I showed a few years ago that I did it when I was at Lockheed, showing the factory of the future. And that's my little avatar there. My daughter calls Monster Daddy because he doesn't look quite right? Didn't cross the uncanny valley. But in this factory of the future, we actually, original version of it, this is a little video we were showing in high schools and stuff to get people to think about the future, but it was completely automated. We had one human being in there, you see in the back, and there was a dog there, and the joke was the human is there to feed the dog, and the dog is there to bite the human if he ever touches any of the automation. But we had robotic systems, we had 3D printing, and we had even molecular computing, where we're not computing, but actually molecular manipulation. We're actually manufacturing at the molecular level. So those are the sorts of things Lockheed was thinking about before I left 5 years ago. So I have no idea where they are now, but at that time they'd already bought the first quantum computer and things were moving pretty fast. But this is what happens when you have this increasing automation is automation becomes capital. So capital can put money into automation, and it's much cheaper to achieve objectives there than to hire human beings who, they get sick or they need health insurance, all these sort of support mechanisms. And that's where, years ago, we were looking at how much we were offshoring to China for building our laptops and our iPads and our iPhones. And even then in this Simulation Century event, I said, that's just a passing phase. What we really need to be thinking about is this, because at the time, Foxconn was already building their robot army. I remember the last time I tracked it, well, when we first looked at it, they had a couple 100,000 robots. Today, they have an army of millions of them. And it's so much easier to have robots than to have humans doing some of that repetitive labor. And it's much cheaper. And but of course, the ultimate implication of that is if it's all automation, then we can build our iPads in Modesto, California, right? And just have all robots working there. There's no reason to send all this stuff to China or India or anywhere else and then have it shipped all the way back across to us. So that's what's happening. But this is something to keep an eye on, and it is going to have disruptive effects on society to see this battle between labor and capital be exacerbated by these automated technologies. All right, so that's where I usually remind people that the Stone Age didn't end because we ran out of stone. Someone came up with a better idea, and that's what we're looking for here today, is to provoke some more thinking and come up with some better ideas. All right, so I'm going to first try to go through and do my best to provide service to Michael's great ideas. Michael Levy is someone here in the Triangle in North Carolina who's, again, working with this Digital Health Institute for Transformation. He's pulled in a lot of support among the universities here, UNC, Duke, NC State, some of the community colleges, really thinking through the sort of first principles idea of how do you create wellness in your community. And that's how I started, how I first met him and got interested in talking with him, and how we formed our partnership is because I really love it. Those of you who know me really know that I really love those kinds of ideas. Let's take out a clean piece of paper, get down to first principles. And for example, thinking about education, if you remember when I joined James Cameron's board, the board of his school out in California, I was excited about the idea because he's like, what kind of people do we need to make for the 21st century? What is the purpose of education? Asking those really fundamental questions and not looking at any other methods we use for education, sort of building it from the ground up. Michael's doing the same thing with healthcare, not trying to build on existing systems, but looking at how do we achieve wellness? What are the sort of social determinants of health? What actually causes someone to be ill or sick, and how to treat it, not just by like how many medical interventions can we sell to a person, is how many drugs, but are there ways to intervene earlier in the progress of that illness or before the illness even starts to make sure that there's wellness. And I know some of these ideas have been around for a while. People are talking about it. And the big challenge that we have in healthcare, of course, is aligning the incentives. Very similar to education, as I just mentioned there, is, figure out where you want to go, take out a clean sheet of paper, and let's design all the incentive systems, the technologies, the people, the support. Think about that complete solution and what we need to do to achieve the end result, instead of just trying to hack on top of stuff that we've been doing for 100 years. So that's the idea behind the DHIT organization, and just recognizing like this, the stuff are all seeing in the news and around things like depression and especially here in the U.S., increases in diabetes and health issues that are a huge part of why we have even a deficit, right? Because it's such a big percentage of the amount of money we end up having to spend in states and at the federal level to support people who just aren't healthy. And the cost of care is becoming really expensive, partly because of the extra cost of some of these technologies bear to extend life. But I wrote years ago about how when you're admitted to a hospital today, and it could be right here in North Carolina at UNC or Duke, you have about a 13% chance of being harmed by your care. It has nothing to do with why you went in there. And it is because of the increasing complexity of healthcare. So again, it's time for a clean sheet of paper. It's time for some first principles thinking to address these major issues. And that's what DHIT is doing today. And he has deeper descriptions, which I won't be able to do justice to, around what we were doing in the old world and how we need to get to the future world of healthcare, where it really is patient-centric and where we as patients have some more control over how we actually achieve wellness and make better decisions around our care. Today, what do you do when your children are ill? You go to the doctor tells you what to do, and you do it. Very often you don't get the chance to say, like, okay, if I know that I need this procedure or that procedure, how do I shop around and find the best match for me that has to do with, my genetic makeup, my specific situation, and that sort of thing. Hey, Will, can you put some of the folks on mute there that need to be on mute? I don't want to call out names, but I was, in fact, this is something I saw just recently, where we were looking at getting for my family, getting some of the antibody tests for COVID. And we called up the insurance company and said, hey, we want to go get this done. We've had some regular tests, but we want to do the blood antibody test. So how is that reimbursed, and how does that work if my whole family does it? Oh, there's a magic code. If you have the right code and your doctor puts the right code in, then it's actually 100% covered. And we're like, oh, great. What's that code? It's like, well, I can't really tell you what the code is, but if your doctor knows it and it matches up, it's going to be great. I'm like, what kind of game is this? Right? I don't have control over it. It's like this conversation between the doctor and my insurance provider. That's not how this is supposed to work. Anyway, so that's generally what we're talking about here. And Michael has this idea of the healthcare utility grid, where it's not just us having to deal just with insurance companies and whatever our doctors say and whatever the pharmaceutical companies say, but we are driving it a little more, that you can actually have people in the field providing prognostic guidance and looking at, like I said, some of the social determinants of to address things like food deserts and lack of activity or mobility, people not going and getting regular checkups, and nutrition and those sorts of things. And those trying to address it at that level by having people in the community who have a different job. He has this idea of a healthcare architect who goes in and looks at working with people in the community to make sure that they know all the choices available to them and what the effect of those is going to be long term. I think those are really exciting ideas. So that's the general idea around the healthcare, the health utility grid. Now, we've been talking with them for some time around how do you bring machine learning, AI, automation to the service of those sorts of things. And that's one quick idea I want to share with you before we move on is, in a previous session, I talked with you about our ability now to take the data exhaust that humans give off out there and take that and model people. So we can make synthetic models of people, put them into simulations, and test ideas. The low-hanging fruit for that so far has been in consumer marketing, where, instead of doing focus groups and surveys, and I talked about this, I know, last year at SimCentury, but it's really progressing pretty fast, where there's so much information out there. We can harness that. We can build these synthetic models. What I'm showing you there, this happened since the last presentation last year. Stan Lee died. We were able to take machine learning and go harvest all the information that Stan left behind, his data exhaust on the internet, his Google footprint, all of the interviews that he did on television and radio and in print, harvest that and make this model of him. And we can actually talk to him now. So we can talk to him. We can see what he's reading. We can look at what he might be doing were he still alive today. So let's take that the next step with thinking about the health utility grid and us wanting to take control of our own healthcare. Imagine being able to take every healthcare intervention you've ever had, every, things like your own genetic makeup, your the sort of health history of your parents and ancestors, have that feed into this model of you and your activities that you're doing every day. What are you eating? How much are you exercising? What's unique about you? And actually, with your doctor or your healthcare architect, sit down and grab this little slider and head out into the future and see, like, when can I expect to start seeing system failures of different kinds? How do I flatten out the trajectory so I can live to a ripe old age? And what little interventions can I take? And again, it's this sort of really deep data fusion model. And how many of us are doing that today? Most of us are sort of, healthcare is something that's inflicted on us. It's not something we can control. So I love this idea of being able to harvest data and make data-driven decisions about our own healthcare, but also sit down with a doctor, what sort of pharmaceuticals should I take, if any, and sit down with a healthcare architect who's telling me about specific exercises I could do and changes to diet and that kind of thing to really achieve I want to live longer and healthier, right? So that's really interesting. I want to talk about some of this other stuff a little bit later. Actually, I'm going to talk about it quickly right now, and then we'll move on. But one of the things we talked about previously is this idea of, and this is important because we're in this election year. We know, you saw this session that I did previously with the RAND Corporation and the Pentagon around narratives and information warfare, just acknowledging the fact that social media is really great, possibly for connecting people to each other and allowing us to communicate around ideas in a different way. But like most technologies, it's a double-edged sword. It's being actively used against us, not for good. And there are competing narratives, right? We're seeing that very deeply right now in the middle of the pandemic, where there are competing narratives about what should we be doing? What should we be taking hydroxychloroquine or not? Should I be wearing a mask or not? Should I be social distancing or not? Is this whole thing a hoax? And that's why I keep talking about getting to systems like this that are data-driven and expert-backed that will let us make better informed decisions. Just because all of us are on the net, that doesn't mean all of our opinions are of equal value. So how do we actually model that? So one of the things we're doing together with DHIT as well is this idea of, hey, let's look at social determinants and all the other aspects of healthcare, the epidemiology of all this, but let's also, and I'm going to try to show you this real quick. Hopefully this is coming up. Is this showing, Will, or anybody who can give me some feedback?
Yep, we can see it.
All right. So here's a simulation. So imagine like this is Stan Lee or anybody I've got modeled here. Here's 10 models of groups of people, their values, their traditions, their behaviors, their attitudes. Now I've got competing narratives. One is, hey, it's a hoax. You don't have to worry about isolating. You don't have to stay at home and shelter. You don't need to wear a mask. So that narrative starts playing. And then you've got a counter narrative that says, really, let's try to do what Italy did and some of these other places that seem to have addressed effectively. And let's stay at home. Let's wear masks. Let's take some preventive measures. And I'll just run a simulation here to show you what these, in this case, just 2 competing narratives. But I've got these 10. If I start hearing, from people's like, oh, it's not true, and I'm not hearing the other side of this, then we start seeing this horrible behavior. So there's 1,000 people here. Each of these are represented by 10 people in here. And I'm seeing the red is people who are getting infected. The black is people that have died. Over here, I'm tracking in my little simulator over time, when you see the infection rate exceed the capacity of care, which is this dark line here, the deaths accelerate and I have a horrible outcome, right? And let me reset it and run it again. And we've got just Oprah telling me stay home. And that's the other idea. There's messages that are out there. And if they're reinforced by certain people, influencers, they have bigger effect on different people than if it's just a message sitting out there as a public service announcement, right? So obviously when Oprah says it, everybody does it. Here, everybody stayed home. We still had a bunch of people exposed. I have to look at the model here, and some people died, but it was not nearly as bad as the previous one. So again, that's the idea of like making this relevant today with some of the issues that we have with the pandemic. All right. So what I'd like to do next is introduce our next speaker. So you're probably tired of hearing me talk. I didn't know I was going to have to do 2 of these, but I think we're in good shape. Heather is someone I met. We met actually on our way to a space event at Canaveral back in December through a mutual friend at UCF down in Florida. We were both at this big conference down there called ITSEC. We shared a Tesla ride over to this event in the evening underneath the space shuttle. It was really amazing, and talked quite a bit about what she's been doing in this field of looking at blockchain and how to apply that to health, how to help us with privacy, and that sort of thing. So I'm very pleased to introduce her as a friend and a great contributor to a lot of the big ideas that are going to shape our future. So thank you very much for joining us, Heather, and you may share your screen at your pleasure.
Thank you so much, Richard. That was such a wonderful Tesla ride over to the space shuttle in Cape Canaveral, and I'm so delighted and honored to be here. Hi, everyone. I'm Heather Flannery. I am the founder and chief executive officer of Consensus Health. And let me just make sure I'm in presenter mode. All good? All right, terrific. So I am looking forward to telling you all about blockchain, its role in incentive design, and our particular vision for the role of agent-based simulation in the future of federated and mutualized infrastructures. My particular point of view is from the healthcare and life sciences perspective, where we focus globally. And I think before we get into defining terms and really thinking about what this is for those of you that are new to this technology, I think I want to start by first giving you a sense of how much momentum is going on and what a global phenomenon it is in terms of large enterprises working with this emerging set of technologies. And you can see this work has been going on for several years now in some cases. The Synaptic Health Alliance at the top was announced in April of 2018. Before the announcement, there was probably 2 years of discussion and engagement about how these parties could work together. In the Melody Federated Learning Consortia, you have now 14 of the largest pharmaceutical companies in the world. Out of the European Union, there is a public-private partnership under the Innovative Medicines Institute focused on drug discovery Here in the United States, the Health Utility Network, with many of the largest players, are all focused on different ideas about how this technology could be used. One downside, though, is that if each of these parties builds a blockchain network shared among its trusted participants, one could envision that as just another silo in healthcare, even if it's a much larger silo. So personally, one of the things that I'm very passionate about is ensuring that the future state of healthcare does not look like blockchain networks that are just great big versions of the silos that we deal with today, that aren't interoperable, where identity is not portable, and candidly, where the consumer, the individual, lacks standing in their position to the ecosystem generally. But overall, this is incredible news. There's so much going on. It's such an active space. It's incredibly fast moving. So thinking about, okay, what are all these organizations doing with blockchain? I bet you that you would agree with me that you have a sense of what blockchain is, but it is always a little bit confusing and for some reason kind of elusive, difficult to put your finger on a definition. And the reason for that is that there are many different lenses through which you could examine this technology and define it. And all of those lenses would be valid or true. So the first thing to know is that it is a layer built on top of today's modern Web 2 infrastructure. And it consists of 4 different macro components. At the lowest layer, they are networks, blockchain networks, where every participant in that network is using what's called a consensus protocol, of which there are many and competing consensus protocols to assess whether an assertion that one network participant is making is agreed upon and true for all the network participants. And only if it is, will that data or that information or that decision be persisted in a blockchain. And then after the fact, it is very, very difficult to change. Some people say immutable, but that may be a little bit strong. I think it's fair to say extremely tamper resistant. So the notion is, in today's world, every enterprise maintains its own infrastructure, its own systems of record, its own data sets. Every process, business, clinical, scientific process that happens outside the 4 walls of one organization generally involves multiple parties coming to agreement about data that is often disputed in status or stage, in details, sometimes in ownership and governance, you name it. When those network participants are part of a value chain or an ecosystem, it removes anything that they decide to deploy in a blockchain network, moves out of a state of it being even possible for them to have disagreements about the way transactions flowed. They come in 3 macro flavors: public blockchain networks, private blockchain networks, and those that are hybrid, where they are bridged or tethered between a private network and a public network. The public network everyone has heard of is the Bitcoin blockchain. That was the first blockchain network that ever went live. That was the core invention of the anonymous founder Satoshi Nakamoto, that we still don't know who that is. And it came about as an act of civil disobedience following the last financial meltdown in 2008, 2009. And so the Bitcoin blockchain is a miracle in the sense that it is owned by no one, it is controlled by no one, and it has no CEO, it has no board of directors, it has no stakeholders. The miracle of it is the behavioral economics that was blended in a new way with computer science to be able to bring an infrastructure into existence, maintain it for many years, it's going strong, without any form of centralized control, and across not only organizational boundaries, but national boundaries, something that operates globally, disconnected even from governments. In 2014, several years later, the Ethereum blockchain was launched. And that is the particular blockchain where I specialize and my organization, Consensus Health, specializes. And it is distinct from the Bitcoin blockchain, which was a special purpose network solely to run one kind of application, money, digital currency. That was solely what it is designed to do. But Ethereum is distinct from that in that it is more of a global state machine, a world computer that allows you to run any kind of functionality on it in this model using this infrastructure, including currency applications, but vastly broader than that. A characteristic of the Ethereum blockchain that's not present in the Bitcoin blockchain is this thing called smart contracts. And these smart contracts work both in public infrastructure implementations of blockchain, like the Ethereum mainnet. It also works in private networks, like enterprise Ethereum networks. Smart contracts are not smart, and they're not contracts. The naming convention is terribly unfortunate. But the fact remains that for you techies out there, what they really are distributed, cryptographically verified, stored procedures. But they're microservices applications that facilitate automation. And critically, it's the first infrastructure that has ever existed that facilitates automation across organizational boundaries versus automation within the four walls of any given enterprise. Large-scale, rule-based automation. And every decision that is made, every action that is taken is longitudinally persisted to whatever blockchain protocol is being used with that smart contract. Very, very critical idea here. Optionally, depending on what scenario you're dealing with, you can use tokenized assets. This is really important because this idea of digital scarcity is the heart of why incentive design can be used in blockchain networks. Tokenized assets can be made to be fungible or non-fungible, and you can create scarcity and therefore convey and imbue value. Those can be minted, secured, transferred, and traded, and it's far, far beyond only money or currency use cases. Anything that you can imagine that you can assign a unit of value to, you can generate a digital token that can then be moved and traded and exchanged and incorporated into incentive design. Also, those things that are unique or singletons can be represented in what's considered a non-fungible token. So when we envision these future state architectures, we're usually talking about multi-token cryptoeconomic systems that need to be optimized, which we'll get in a little while to what I'm going to be telling you about. And then lastly, the user experience on top of blockchain is called a DApp for a decentralized application. But if it's designed well, the end user shouldn't know that it's any different from the kinds of mobile applications or other applications they're used to today. So my company, Consensus Health, has created a technology stack we call elevated compute. And elevated compute takes everything that blockchain is, but it adds two other families of emerging technologies. We call those privacy in depth and decentralized AI. And I'm going to be telling you a little bit more about what those are soon. But the key is that my view and my organization's view from the perspective of healthcare and life sciences is that blockchain technology is on the critical path to the positive transformation of our industry globally. It's absolutely necessary, but it is not sufficient. So why isn't it sufficient? What's the problem? Why is that family of technologies so important yet incomplete? Well, in our industry, we have a range of barriers to adoption, and we're working on these across the board. All those organizations that you mentioned, almost every government in the world, we all have our sleeves rolled up, working out how to address these issues, particularly for our industry. So cybersecurity is a double-edged sword. Let's start there. In one sense, decentralized and federated data structures are inherently have an improved cybersecurity posture. And that's because they disincentivize a criminal hacker from putting in the the effort to breach a system. And that's because if data isn't centralized, then what they would be able to obtain from a breach is orders of magnitude less significant. It is much less. So from a cybersecurity perspective, it creates a disincentive because you are decentralizing rather than centralizing data in a blockchain infrastructure. Further, the integrity of that data, the provenance of that data, because of the transparency and the immutability intrinsic to blockchain data structures and architectures, you have a vastly higher integrity data set when it is sourced and originated and coordinated via a blockchain infrastructure. But that all sounds wonderful, right? So why is it a barrier? Well, lots of reasons. First of all, hundreds and hundreds of millions of dollars in crypto have been lost because the applications, not the blockchain itself, which has never been hacked by anyone, but the applications where you hold crypto assets and tokens that reside on your phone, those have been breached and hacked. The standards that are used to approach security authorization processes, what we think of as defense in depth, all require a certain notion of a system boundary. And blockchain infrastructures break our notions of system boundaries and make our methodological approaches to cybersecurity complicated, and the standards that we adhere to don't always match. And I'm not going to talk through all 5 of these, but I would like to hit on the fact that compliance burdens are enormous. And once again, in our industry, we have difficulty with adoption due to compliance. We also have the opportunity to present this technology as RegTech, which is really important. Identity could be a 2-hour-long talk all on its own for the implications of a person-centered architecture in healthcare. In this world, that maps to decentralized identity, something called verifiable credentials, biometrics, and what I think of as a self-sovereign data lake where n equals 1. And those 4 components come together to form a person-centered architecture that is only made possible by this technology combined with other technologies. I'm going to be talking more about privacy, and bioethics is incredibly important here. Our industry hasn't had an upgrade of bioethics for over 30, almost 40 years. We have radical disparities in our industry, and it's vital that we take a bioethically intentional view as we architect these new systems. So as we look at what is going on, we have a framework for thinking about how each of these use cases can be adopted within these barriers. And I developed this called the PHI Readiness Framework. As you can see, time and the involvement of PHI, or protected health information, you could think of that as identified health data across the x-axis, and population health impact along the y-axis. I've broken our stages of transformation into 3 stages. We are right now entering stage 2. The key is that everything that already has traction, that is in production today, does not use any PHI at all. And you'd think that's unintuitive. You know, what can you do in healthcare without ever touching clinical data? Well, it turns out quite a lot. Supply chain optimization, provider directories, various aspects of revenue cycle, credentialing, lots of things like that. Over on the other side, into stage 3, we're dealing with fully identified sensitive PHI. And what are some of the holy grail things in that area? Well, it's care coordination across organizational boundaries, clinical integration, the realization of the vision of precision medicine, the transition from volume to value, the idea of digital therapeutics becoming completely mainstream. So what's in the middle? What's this gap? Well, I would argue that all forms of IRB overseen health research is the bridge between stage 1 and stage 3. And we're seeing this begin to happen now, where effectively any of the things that you could do in mainstream medicine in stage 3, you can bring into stage 2 and do it now under a well-constructed research protocol. So when we look at the underlying data architecture that we're dealing with, we're basically talking about a centralized data approach in a world where the data has already been exponentially increasing and is only continuing to do so. So our thesis is that we've really reached the logistic extremes of data lakes and other centralization strategies. So we're working with a new set of semantics for data to describe the way that we're approaching this. But metadata, everyone's familiar with it, happy term, everyone knows, but we try not to use the word data by itself beyond that, because it ends up becoming meaningless in the ocean of data. So we talk about source data as meaning enterprise data behind firewalls, generally at rest, or patient self-sovereign data that could be in any cloud storage infrastructure, at the edge on their device, et cetera. And this has been expanding exponentially for the last 15 or more years, and the growth rate is only increasing. When you add 5G and IoT to it, it's absolutely extraordinary and overwhelming. Everybody thinks they want more and more source data. How do I get access to more and more source data? But what they really want is the derived data. They want the analytical findings and insights. Right now, people believe that they have to get a hold of the source data, or they will not be able to perform the analytics to arrive at the derived data. That's because they don't trust data that they can't see, and they don't trust analytics that they didn't perform. This is at the heart of both the psychology and the technology that's going on. So we believe we are right now in a sunsetting paradigm for how it is that you create value out of data. Today, it is slow, it is labor intensive, it is error prone, and it is untrusted. That is, the more true that is when you're talking about ecosystems or markets as opposed to single enterprises, which still have their own complexities. In our emerging paradigm, where it's going to be rapid and automated, quality controlled and trusted. Instead of copying and moving data from place to place, always infinitely moving and exchanging data, we believe source data is going to remain where it was originated for the most part, and that while data exchange will still be necessary sometimes, it will become more of an exception instead of the rule, and that federated first architectures will become the new rule, where analysis is performed in federated networks, source data is able to remain fully identified and therefore clinically actionable because it is not exposed or shared or transferred. The normalization of that data so that analytics and learning functions can be performed, instead of happening, in a labor-intensive way, it happens locally where the data resides versus via distributed rule sets and associated automation. And then finally, the analysis itself is local, and then the combination of derived insights is shared with federated network participants. This ultimately leads to the ability to add the tokenization layer for incentives so that you can create the incentives that will counterbalance the distorted incentives everyone understands are already present. Because it simply introducing the technology in and of itself is necessary, but also not sufficient. We have to be able to create incentive structures and then continuously optimize those incentive structures until we see the entire complex adaptive system begin to pivot in the direction that we're seeking, which is a thriving and well population. All of this leads to what we think of as the acceleration of research for faster miracles and real-time, real-world evidence. So as we talk about the blockchain pieces of it, I mentioned privacy in depth and decentralized AI. So what is privacy in depth? Privacy in depth is a bundle of emerging technologies that you can see on your right there. We are incorporating all of these methods into our technology, but I want to hit two that are incredibly important, and they are zero knowledge proofs and trusted execution environments. Zero knowledge cryptography is brand new math. It's brand new cryptography, which is distinct from blockchain generally, which is really old cryptography, nothing new. Public key infrastructure, that's not where the innovation lives in blockchain. Zero knowledge cryptography and zero knowledge proofs are something entirely new. And if you're not familiar with it, basically you could have any business or clinical process that needs your birth date today, you have to fill out a form, send your birth date somewhere, and then the other party has to retain and govern that data and comply with that data and so on. In a future where zero knowledge proofs have been brought to global industrial scale and implemented in blockchain networks, instead you would be able to pass a cryptographic proof that your birth date did or did not pass a rule set. Really, really important. And trusted execution environments bring in the hardware dependency. How do you know that a piece of hardware was trusted? How do you know that the algorithm or the piece of software that's computing on your shared resource actually hadn't been tampered with since it was last compiled? So this whole notion of trusted and verifiable compute becomes much more important when you're not inside the four walls of any enterprise, but instead you're now in new mutualized and federated infrastructures. And lastly, decentralized AI involves how to conduct not only analytics, but learning and secure trusted verifiable inference in these federated networks. And this is where the use of intelligent agent-based automation comes in, because we can, in the multi-token crypto economic systems that will define this future state, we can run a simulation environment in parallel and continuously work to optimize behaviors and be able to update those incentive structures. So all of this, we believe that even though most of these federated networks will be private, there has to be a public infrastructure in the background. That is the only way that you avoid creating larger and larger data silos. We view the Ethereum mainnet, which is a neutral public resource, the world's computer, as vital to that. And when we implement enterprise Ethereum networks, they elegantly interface with the Ethereum mainnet that is public, and that allows resources to be discoverable. I mean, imagine the internet if there was no domain name service, right? Same in our future as we look at this and why that's so important. Ultimately, we're driving for total care engagement around a person. And the combination of these technologies with tokenomics that comes in with blockchain allows us to use behavioral economics and gamification in entirely new ways. And I will go ahead and close it out there, and thank you very much. Looking forward to the Q&A segment.
Wow, that was fantastic, Heather. There's going to be tons of questions. I was getting privately pinged by a bunch of people about this. So but we will handle all those questions the best we can when we get through this next talk. But will also be of equal interest. My colleague, go back, gosh, over a decade, in the early 2000s, we were working with the ADO Collab on the original definitions of SCORM, the Shareable Content Object Reference Model. And ADO Collab SCORM S1000D testbed, where we're trying to figure out how to get training and technical manuals connected up together in one process. Working with Phil Dodds, the guy who played the organ in the movie Close Encounters of the Third Kind. If you saw that, we were working on these standards. So he's been at this for a while, tilting at windmills. Just moved from Ojai, California, one of my favorite places, to Washington, D.C., and is trying to help bring all this great technology to the Navy to automate a lot of processes and achieve that human-machine balance. So looking forward to hearing this talk from Wayne, and please join me in welcoming him. Thank you, Wayne. All yours.
Well, thanks, Richard. Heather, you blew me away. Richard, why did you have to have me follow Heather? That's a tall order there. A lot to learn. You sort of lit some light bulbs in me, and hopefully some of the little teeny things that I have to say has some kind of connection to what you're what you're talking about. But really, really nice to hear that, and kudos. So yes, so my name is Wayne Gafford, and I am going to be, before I share my screen here, I'm going to be talking about some things that probably 25 years ago I could have never, ever, ever imagined that I would be in this position. Back in 1990, I graduated from Marymount University here in Arlington County with a master's in education and a high school English teaching credential. And I thought I was going to be a high school teacher. Well, you know, halfway through my student teaching, I realized the last thing I wanted to do was work in a public high school. And one thing kind of led to another and led to another, and I suddenly found myself in what was then, way back in 1992, technical manual publishing and some of the first SGML days, separating content from markup. And that gave me kind of like my very first idea about data. How does data use? How is it structured? What's its value? How do you move it around? How do you get more people involved with it? How do you reuse it? You know, lots of different types of things. And now, you know, shoot all the way down here to 2020, and as Richard alluded to, for the last 15 or so years, I have been working on these ideas on how do we take data that's part of the technical system space, technical products that are in the Navy, sonar, radar, anything that gets deployed to the fleet, anything that's engineered. And how does that data actually connect to the data that's needed to train sailors in the fleet to operate that? We've had a very big disconnect over the years about making those types of connections. And what I'm going to do is share my screen and make that segue here into that. Let me go and get go into, let's see. So what we have done up to this point in time has been I would say a real feat in being able to take the data that is part of a system, engineering data, reliability data, maintenance data, anything that requires a kind of a top-down breakdown structure of technical information that sustains a system, and how do you use that information to come up with the competency frameworks that people have to know in terms of knowledge, skills, and abilities that would qualify them for the jobs in the Navy to operate on those systems. And so what I'm about ready to talk about is really, it's not really part and parcel and unique just to the Navy. These ideas that I'm going to be talking about can be in the military sector. It could be air, land, or sea products. It could be Army, Navy, Air Force, Marines. But these ideas I'm going to be talking about can also be out in the private sector. They can apply to Caterpillar. They can apply to motor companies. They can apply to any type of companies that have engineered systems or systems that require ongoing maintenance. And how do you actually get into those systems and into that product data and extract out the learning requirements, the things that you have to teach somebody, the things that somebody has to learn to qualify for that. And what we have been able to do is come up with a project that is out of my space where I work in the Navy called OpNav. And I am in an organization, broadly speaking, called OpNav N1. It kind of supports the human resource aspect of the Navy. It supports a lot of training and learning stacks. It supports a lot of things that have to do with everything from issuing paychecks to uniform policy, all sorts of things that have to do with the person. But in my particular role, and what I'm sort of bringing to the table with the long combination of being in graduate school for education and understanding curriculum, curriculum planning, lesson planning, working in the classrooms, all that kind of stuff. Then finding myself into technical publishing and understanding the nature of data, I have found my way into a very unique place where the Navy is now beginning to adopt at the big level Navy, the way we extract competency frameworks directly from what we call maintenance task analysis for a system. And what this presentation is a very, very severe distillation of a longer paper that is linked here in my presentation that I did for ModSim. I'm not going to go into all of the tangents, but what I'm going to do is really kind of focus on one kind of thematic thread, and that is, how do you get from the actual data that makes up the task analysis for that system, and then the output of that would be the actual learning objectives and competency frameworks that you need to teach. And I think Heather sort of tripped upon something that made me do a double think, and she talked about the differences with source data versus derived data, that maybe people don't need their source data, but they really want the derived data. So in this regard, and maybe as a segue of context with data in a very small thread going back to Heather, the idea, if you were actually responsible for teaching a course, or a very complicated course, I mean, we're not talking about, you know, rubber bands and tacks. You know, we're really talking about very sophisticated radar systems that need constant maintenance, constant oversight in all sorts of environments. Well, if you are on the hook to teach these types of concepts and activities, you may not be the whole expert on the 3D models that create those systems. You might know you may not know what the fault tree analysis is in predicting when's the next, you know, fault going to be. But you certainly do know how to teach a class, and you know you want that authoritative source in the maintenance task analysis in order to get at the derived data, if I'm understanding you correctly, Heather. And the derived data would be your competency frameworks, which winds up being the very things that you need to design a course around in order to teach it to individuals that need to qualify for positions, gaining credentials, and then moving up through their ratings, if you will, or their career paths. So that is sort of like a broader context of what I have sort of grown into. And the talk that I would like to give now with regards to the paper is, how do we actually get from that data that is not oriented towards training, but look at that maintenance information from a training perspective and extract out all the requirements that you need to teach that course, and all those requirements that a sailor or a student needs to know in order to prove his or her proficiency and qualify for that work. So the title of my paper here is Natural Language Processing to Extract Technical Competency Frameworks from Maintenance Task Analysis. And this is part and parcel of a larger project that I have created and I'm running called Acquisition Requirements for Training Transformation. And it really is part and parcel of being able to take training needs analysis, which has always been separated from product support analysis, and fusing them together as one. Let's see. So, let me go back. Okay, so let's look at first right now the current state of where training data is in the Navy, and really, frankly, a lot of other places. Historically speaking, actual training information has never been configured or linked directly into system product data. And the problem with that is that if I have a change that has to go to my system, it's either a design change, an engineering change, or maybe it's a change on how I support the product. We don't know all of the different training assets that need to be reviewed according to that design change. We know what the tech pubs, we know about the parts, we know about the reliability, we know about the maintenance tasks, and all that data that is linked remains concurrent through the life of the system, but not training. They're always the last to know. Historically speaking, business processes have been that a technical manual be created, distributed to a schoolhouse. The system has been deployed, And now the course instructor, whoever's responsible for the course, has to go through those pubs and figure out what's new. And by the time they find out what's new and put things on contract, you know, they're 24 to 36 months behind. And oh, by the way, here comes a new technical manual. So that current state is now currently being overcome so that we actually treat technical training information as a first-class citizen in the life cycle support of that deployed system. Now, the state of the art, and no pun intended, but yes, pun intended, the state of the art is that we actually have training requirements that are directly linked to tasks. So one individual task is directly related to a corresponding learning objective, and then when there are changes to the system, we know exactly what tasks and learning objectives need to be reviewed. So our curriculum development is linked to that product data and that cycle, and that is extremely important in these complex systems that require constant oversight. Now, what I'm going to show here next, let's go. Let's see, how do I do it? Come on. Oh. Trying to go forward. Why is that not going forward?
I would say use your scroll wheel, but I know you're on a Mac, right?
Yeah. I just don't understand why it's not going forward. Okay. Do I have it here?
Are you using, what program are you using to show this?
Google Slides.
Let me go.
The slides you're presenting.
There it goes. Okay, I'll do that. Okay, I found it. So what I'd like to do is I have a 2-minute and 45-second video that gives you a broader context in exactly what the issue is, what ART is doing, and then what the upside value is. And what I'd like for you to pay attention to is somewhere in the middle of the video, you're going to hear a phrase that says, ART injects new technology. And you'll see these arrows that kind of go to these different icons. And that essentially is what I'm going to be talking about after that video. So let me play this, and this will set some more context for my next slides.
Product lifecycle management and support activities across industries require managing complex engineered systems with complex data. Lots of data from multiple sources and multiple formats. However, Navy technical training data are often disconnected from maintenance, operations, and troubleshooting task requirements, leaving stakeholders and sailors without the accurate, timely information needed for optimal readiness. These disconnects cause delays in achieving training requirements, leaving sailors unprepared and impacting job performance with potentially catastrophic effects. The Acquisition Requirements for Training Transformation Initiative, ART, is addressing this serious Navy readiness issue by digitally integrating the management of technical training assets into model-based product support to ensure sailors get what they need in real time to perform their jobs. Processes within Product Lifecycle Management Systems, PDM, Product Data Management, RAM-C, Reliability, Availability, Maintainability, Cost, and LSA, Logistic Support Analysis, digitally thread engineering data to product and service lifecycle management data through common industry standards. ART injects new technology that extends this digital thread to training data through new algorithms that assist maintenance planners and training analysts with rapid decision support analysis by extracting core competencies from the authoritative maintenance task analysis data source, automatically down-selecting training tasks, and then generating the performance objectives deemed critical to support readiness. ART also assists curriculum developers by generating course outlines from the performance objectives and enabling them to design and manage multi-format curricula, all of which remain linked to the authoritative product source data. Now complete, ART transforms training into actual product data, digitally threaded by unique system identifiers for a truly integrated lifecycle data enterprise, where real-time analytics can be collected to help maintenance and curriculum planners monitor and improve training effectiveness, leading to related training data being identified in real time in response to an engineering change proposal, accelerating stakeholder analysis in the design and delivery of new technical curricula, ensuring the Navy's technical training is accurate, on time, and continuously improving job performance. ART, it's transforming product lifecycle management and support for the future, maximizing system, sailor, and mission readiness.
So that was the overview of essentially what we have been working on for quite some time. And what I'm going to do is focus on a very narrow aspect of this that that Richard had requested, and talking about a little bit about analytics and AI, machine learning, artificial intelligence. And in this particular case, we're going to talk a little bit about natural language processing. That really is a technology that we have employed here together with industry-based data standards, W3C data standards like linked open data that drives a semantic web, and the use of those of exactly how we actually get into the data and extract things out to get what we want as derived competencies. So this is what you're looking at here. If you just slow your eyes down a little bit, I don't want it to be too much of an eye chart. I usually have this to be an animated build slide. But if you just focus on the column on the left, where it says product structure and maintenance task analysis. And this sort of helps paint the picture of what it is that we're dealing with systems that are deployed to the fleet. And some people call those systems an end item. They're a product. They could be referred to as anything. But these end items, they have subsystems. And those subsystems have subsystems. You can go down 3, 4, many different levels. But if you see there on that column there on the left, you'll notice that every subsystem and every system is going to have a suite of tasks. There may be operational tasks, they may be maintenance tasks, they may be troubleshooting tasks, they may be any number of tasks. And it's the data that describes the tasks that winds up being the birthplace of what it is that you need to teach in the classroom. So one of the unique things that we have done in our work is that rather than look at a particular term about task analysis and look at it at its definition as if I really was a maintainer, we keep the definition of it as it is, but we look at it from the perspective of someone who needs to teach it. And what does that actually mean? Does that mean that this piece of information has to do with the audience that has to use this data? Is it the behaviors that somebody has to perform? Is it the conditions underneath, the conditions that they have to perform the behaviors? Or it might be the degree or standards by which they have to perform. That was our initial sort of learning, training, educational goggles by which to reinterpret this information. So if you look at the column there in the middle, you'll see that that column has to do with learning objectives. So we have terminal learning objectives, we have enabling learning objectives, and what we have found is that there is a commonality or a structural parallel, a structural mirroring between the learning objective framework and the framework of the system and the tasks that are a part of that. Once we have that aligned, and we're going to go into how we actually extracted that, and of course it goes much more detail in the paper, we then can move farther to the right and we find we have a course content. So we have a course module and we have lessons and we have sections, And those courses and those outlines kind of has a parallel structure as well to the learning objective structure and then back to the system structure. Now, once we sort of have this, we basically have all of the requirements that there is to teach, what someone needs to know, what somebody has to assert through their demonstrating knowledge, skills, and abilities that they're qualified for a job. What this particular slide does not represent, which is still very, very important, but didn't need to go into it in detail, is the actual design of the training. So you can see here on the right, there's a course structure. Okay, those are the components, major components that we have to account for. We have the learning objectives. Those are the things that we have to make sure that we assess. But you can teach those learning objectives, or you can organize that course any way you want and teach it in any way you want. If you want to go lecture in a classroom, knock yourself out. If you want to turn this into virtual reality using haptic, gloves, knock yourself out. If you want to do just traditional computer-based training, knock yourself out. But what we have done here is we have sort of separated ourselves from the actual design and implementation of the course and getting down to the root of what are the training needs, which really is the core foundational pieces of data that really we need in order for somebody to matriculate through a series of courses. And we found in the scope of maintenance tasks, which represents 65% of all the training in the schoolhouses in the Navy, we found that the low-hanging fruit is to start looking at maintenance task analysis and systems and work from there. So this is the broader framework that we have. The top level requirements for everything that you see here in the middle for learning, for training needs analysis, and also for the course structure, and also for course design, have now been accepted for implementation and integration into what is known as NAVSEA's model-based product support, which is a complete overhaul of the Navy's 30 years of logistics systems, data stovepipes, into a more readiness-oriented, data-driven approach to determine cost-effective ways of maintaining systems in the fleet. And we believe by bringing this kind of sophisticated approach to training, this really winds up becoming part of model-based product support. Now, there's actually real code behind all of this. This is not vaporware in any way, stretch of the imagination. I didn't want to go through and do a demo because I didn't think we had enough time. If anybody out there would like to see a full-blown demo of how we actually do this, through Richard or through anybody, we're very, very happy to share what is going to be implemented in the Navy and can be implemented really anywhere in companies or systems or in classrooms that have these types of data extraction requirements for competency frameworks. So let's move on to the next slide, if I can get there. I don't know why I'm having, but let's see. Okay, so let's talk about the data. And this would be what Heather, I think what Heather was referring to as the actual source data in a maintenance task analysis that we would refer to as classes and properties. So you can see across the top, product, product variant, breakdown elements, part as designed, tasks, subtasks, resources. These are all classes or categories of information that go into the analytical factoring of how to maintain a system after the design has been verified and validated and approved. So the actual properties underneath these classes you can see here in these columns. So go to the middle column where it says task. So task is a class, and you can see here all of these different pieces of properties about that class. That pieces of data has to be a part of it. So task, personnel, safety, criticality, if you look right there in the middle. Well, in most of these maintenance task analysis specifications, task personnel safety criticality could equal something like, it could equal A, it could equal B, it could equal C, D, E, F, something like that. But A would have everything to do, A would have something to do with very, very safe, and an F would mean, do something wrong and you're likely to, injure yourself or create some sort of tragic event. And so we take the information, the actual data that's allowed by choice for these data specifications, and we use that data to begin to invoke what the training needs are about that piece of information in your maintenance task profile. So this really is the authoritative source, the birthplace of the things that you have to teach. And we have actually used this information to do several things. Number one, we have used this data to be able to, through algorithms, prioritize tasks to be trained. The way we did that is that we looked at factors in terms of frequency of a task. We looked at criticality of a task. Criticality of a task basically means it's that particular task's integral importance into that system itself. And then importance of a task, which is really defined as the criticality of the human performance in making that task go forth smoothly. So we took those definitions of frequency, criticality, importance, which actually comes out of a model for curriculum development, and we searched through these two different types of maintenance specifications called GIA 0007 and S3000L, and we looked for all the definitions that actually lent themselves to being part of frequency, criticality, importance. And we found clusters of properties that actually had definitions that was thematically about each of those three ideas, criticality, importance, and frequency. And by using algorithms, we were able to take the particular markup in the property that was selected for that piece of data and throw it through an algorithm, and then the output would be a particular order of priority on the tasks to be trained. So once we knew what those tasks to be trained were or are, we then move forward in our next step to determine the level of learning analysis. When we determine the level of learning analysis, we move away from the task itself, and we start moving more into some of the generic occupational standards that are in the Navy, but we also look at things like Bloom taxonomy, and we look at learning domains like cognitive, affective, and psychomotor. And there's a lot of adjectives that are about those particular domains. And so when we are looking in our decision support tool, this is something that we can demo to you, when we're looking at a prioritized task, we can actually apply adjectives and verbs to build up the nature of the degree that we need to teach that prioritized task in the classroom. Once we have that, then we'll go into the next phase, and then this is where in the next couple of slides we will show the actual DNA of how we build a learning objective. We then can go into specific pieces of data and extract out content. And we can then extract that out and then remold that information into the syntax of a learning objective. And so
Wayne, I did want to point out we're at our 90-minute mark here, so that time went by really fast. But I know there's going to be questions around some of this stuff. Is there if you want to just sort of try to finish up, and then we'll dive into whatever questions are out there.
So what I was going to say here as an example, if you look here on the left, you will see a maintenance property, and that property called training equipment requirement code could equal Y, and Y equals yes. But through NLP, what we'll do is we'll translate Y to equal the required training equipment, and we go on and on and on and on until finally when we continue through everything, you can see that the actual learning objective is actually created down there at the bottom. So you go from the name of the property to a specific attribute and the data that goes into it. Then you go through a kind of modified constituency parsing and sequential filtering to get a little segment. And then we apply syntactic and grammatical parsing to it to actually create a learning objective. And that is the way that we have approached the idea of extracting training needs analysis directly from maintenance task analysis that enables us to be training data as product support, using decision tools for training needs, data is accessible to stakeholders, and everything is data driven. And this is just a little quick, this is the top of the paper. There's a link right there. So Richard, thank you very much.
We'll share it. So one of the thoughts here, Wayne, is I know you're big on return on investment. What do you think this program is going to mean to the Navy? Like, have we thought about how we could measure, like, how many thousands of hours of analyst time, or how many millions of dollars this is going to save the taxpayer every year? Has any thought been given to that yet?
Yeah, so there is a federally funded research and development corporation called the Institute for Defense Analyses, and they were part of our project, and they did a cost-benefit analysis for implementation of ART into the Navy. And they found that upwards toward anywhere from 25 to 50% of labor hours could be saved simply by transferring activities in training needs analysis actually upstream and focusing on a more high value data product like the maintenance task analysis. And by having training needs analysis move away from their traditional types of activities and their processes and actually focus in on the data that's upstream that can actually cascade downstream, we can actually save, at least in that portion, anywhere from 70 to 80% of that time, depending on the complexity of the systems and the subject matter experts who are most familiar with those systems. So there's definitely a return, there's definitely a cost benefit, and I can certainly send or share that document because it is open to the public.
Yeah, I think there's that, and then there's just the time to fielding, because, you know, before, if the Navy wants to field a new system, before it can be fielded, it has to have all that stuff around it. You know, you have to have the technical manual, but then the training and the support and all that, all the life cycle maintenance sort of built around it. And the idea of being able to field things faster and get them out to people who need them, our warfighters, I think is really compelling too. So I think that's the overall message is, you know, none of us can really afford to put off some of these decisions about what do we automate and what, you know, should we postpone at all this idea of automating portions of these activities when we know the big impacts that they have. And I know I told a story before about JP Morgan was spending 320,000 hours a year just reviewing loan agreements with New York lawyers at $800 an hour. That's a $300 million cost every year that was just built into their business. They just said, this is a cost of doing business. Once they realized what they could do with that kind of automation, they don't have that cost anymore. They do a one-time investment, and not only does it pay off immediately at some kind of 10x or greater rate, but that now it's an annuity. They'll never have that cost again. And if their competitor or their adversary still has that cost, they're no longer competitive. So that's the kind of stuff we're looking at. Questions? I know we're over time, but I really appreciate everybody hanging in there on a Thursday afternoon. And this has been really exciting, and we'll have the recording of it for everybody. But are there questions from the audience? You can raise your hand or you can type it. We recognize the congressman from Berkeley, California, Rick McGeer.
Well, first of all, I'd just like to say, boy, that simulation you showed in your video, in your presentation or Michael's presentation, that was amazing. Where can I get a hold of a simulation like that?
There's a firm called Engage Lively out in somewhere in Berkeley, as I understand it, who can obviously help you with those sorts of things.
Thank you. Seriously, not to waste time. And Heather, I have a zillion questions for you, but unfortunately we get into the weeds really, really quickly. So Wayne, I'd like to start with a question to you, which is that as I think about the art, um, the kinds of training you were focused on, it was the maintenance tasks, which involve physical, concrete, easily described physical actions and have a concrete goal.
Yes.
It's the radio. And I mean, so one obvious question is, well, gee, is the scope broader? But just within that scope, it seems to me that an awful lot of training that is done not simply for Navy maintenance, but in all sorts of fields, have those two characteristics. And if you thought about the other fields that, when you measure the ROI from this, it shouldn't just be the ROI for this narrow task, but many other things, particularly within the Department of the Navy, that involve doing the same sort of thing. Please go on.
Yeah, that's correct. So when you actually start purchasing, or when you go through acquisition and you are actually purchasing your training content in the very same data formats, in the same schemas as all of the other product data, the return on investment there is such that you now have built-in configuration, you now have built-in reuse, you now have systems that actually can manage and treat that information all in the same way. So why have a technical manual in one type of a format as its authoritative source, and then training content in something else in a completely disconnected environment where they can't talk? You combine that two and integrate them to that two, and you now have the ability to, notify people all at the same time concurrently to say, this ECP, you have to review that, and everybody gets the same message. And this is because it's all formatted in the same way. You all have the same type of metadata. The identifiers are the same currently all the way through. So it is certainly a ripple effect all the way through, for sure.
And doesn't that training material entirely replace the manual?
Well, so if you wanted to go that far and actually create some like of a hybrid, so what we have found is that if you actually use data standards that actually can mesh together, you actually can build into it some training features into it, or actual just maintenance procedure features, and have sort of like a hybrid to where you can like link out to like support material for video of the like. So I think that is what you're saying there is really what is on, what I think is what it's in store, but not just exclusively use the tech pub, like, whatever is between the front cover and the back cover of the manual, but that between the front cover and the back cover of the manual, euphemistically, is everything that you need to know for on-the-job support, any kind of interaction with a back-end database for fault tree analysis, any kind of brush up on things that you need to know for maybe future work, So the idea of modularizing all this types of information and being able to link it together gives you a greater amount of flexibility of not say, I'm going to deliver a single manual or I'm going to deliver a single course. I want to deliver an environment that has a user experience that allows you to get wherever you need to go based on the configuration of the ship and the configuration of the people that are on it. That's where I believe we are going.
Heather, I have a quick question for you. I think what's most on all of our minds right now is we've got an election coming up and we're in the middle of a pandemic. What is the most low-hanging fruit thing we should do in the next 90 days for both of those using blockchain?
Oh my goodness. Is that ever the million-dollar question? Before I answer it, Richard, I just have to thank you, Wayne, for the gracious remarks you made following the talk. You're so kind. I didn't want to interrupt you with yours, but but thank you. In terms of narrowing the field, I would think about it in terms of the critical path. There is a lot of desire to get to the end state by skipping steps in the middle. And while I also want to get to the end state, I want to reach our technical nirvana. There are elements that simply can't be procrastinated about forever. They have to finally be dealt with, and I have to bring identity forward. For example, if you want to have absolutely verified identity with biometric attestations, if applicable, that's a decentralized identity plus verifiable credentials plus biometric stack that would be critical path to anything where you needed concrete, definitive identity that could be used by an infinite number of actors in a trusted neutral system. Likewise, the same technology that can confirm identity absolutely is also the technology that can obfuscate or secure anonymity. Same technology implemented differently. So in the sense of needing to assure that our civil liberties are not compromised and that we are not sacrificing our freedom in exchange for security in a way that we will never be able to roll back, we also need to be concerned about how it is that we can use advanced privacy preserving technologies in those cases where it is appropriate. Ironically, it's the same foundational infrastructure. It's different ways of implementing it to meet certain needs, but both identity and privacy are two sides of one technical coin that we can't address any one niche use case without getting at that big picture.
There's a lot of foundational work that still has to be done. How long is it going to take, you think? I know it's mostly policy. It's the technology's ready, right? It's just policy and people adopting it.
The technology is almost ready.
Okay.
The identity technology is ready. The public infrastructures needed for it to scale are coming along very quickly, and zero knowledge cryptography is working and it's in production, but we're working to industrialize it so it could work at mass volume. But we're close. We're close is my point. And I don't think it's accurate to say that it's purely a policy problem. I think it is a structure problem, and we keep trying to have government go at it or the private sector go at it. And the only model that will possibly work is a new kind or newly conceived public-private partnership. And it can't work otherwise. So I think in that model, within our current policy environment, for example, leveraging the CCPA, it's not just about the right to be forgotten, it's the right to receive a copy of information about you, for example. We're all subject to GDPR and so on. I don't think we need massive regulatory change as a first principle. We need a different structural approach. And that's something that I've done a lot of thinking about, feel passionately about. Thank you for asking me, Richard.
Existential.
I have and this may be too deep into the weeds, but this is a question for Heather. Heather, tell me if you'd like to take this offline. One of the issues in scalability of blockchain, where it is an issue, is that blockchain is a very heavyweight technology and offers very, very strong guarantees. So there are people like Gun Searer at Cornell who says essentially that you can get a slightly weaker form of blockchain that's much more scalable. So I guess the question is there a weaker gun that will give you the privacy and attestation guarantees that you need that will get this done? I
think first, thank you for that question. And secondly, I would say it depends on the context and how widely useful you wish that credential or identity to be used. For example, if you only have a handful of actors, maybe a few corporations and some government entities, and that is the beginning and the end of the context within which something would be used, then certainly you could probably use current state technologies to achieve that goal. Or you could use a private blockchain, which does not have the same scalability concerns. So enterprise blockchain implementations like Enterprise Ethereum, Hyperledger Bezu, et cetera, they're vastly more scalable when we're talking about a private implementation versus the public mainnet, which is not very scalable today. So it all depends on the context. It also depends on whether untrusted actors or unknown parties that aren't sort of pre-built into a workflow need to be able to discover a resource and engage in an automated fashion without human intervention, without paperwork, faxes, phone calls, emails, meetings. That's important too. It's in those scenarios where you want something like that to be able to scale rapidly, where you need a public infrastructure. I tend to believe that what is the right architecture for today is a very, very limited use of public blockchains for certain really narrow purposes, especially including discoverability, where then the vast majority of the work, the storage, the compute, the transaction processing are offloaded into a private blockchain network that is connected or tethered. So that it's only a small, if you think of the total workload, the only portion of that total workload that would be on a public infrastructure, maybe 5%. But they are architected. They are architected as one large architecture.
Thank you.
So I have a fun question for everyone. Did anyone catch the Easter egg in my video stream? Anyone?
Tricky.
Bueller?
Turkey.
None of the Tanjo people, I think, should answer that.
Easter.
You guys know? Yeah, you guys know what an Easter egg is? Rick, you don't see it?
It's still in the presentation
It's right here.
right here. Oh, well, I better go to speaker view.
Well,
No.
it's not the blinking light behind the.
You're close. You're warm.
Oh,
Guys,
it's the, no, it's not the photograph in front of it.
it is actually. So that's kind of a meta Easter egg because it's me with Warren Robinette. If you saw Ready Player One or read the book Ready Player One,
Mhm.
so Warren Robinette is the guy who came up with the first Easter egg in a computer game
Mm-hmm.
when he was at Atari because he was mad about,
Yeah, my ex-colleague.
that's right.
Right.
That's Warren. Lives just down the street here.
I didn't realize you were making a reference to Halliday's Easter egg.
That's right. That's what it is.
I love Ready Player One. Great.
Yep. All right. Well, I know we've gone way over time, but this has been rich, like every SimCentury discussion we've had, and this will live on in perpetuity on the NTSA website. We will edit it down, so share it back with you guys so you can take a look at it and provide it and let you know what NTSA decides to do with it, if they're charging for it, if it's free and open to everybody. But it will hopefully provide some very valuable guidance to the community, and I really appreciate all of you who took some time today to join us.